Okay, so trial and improvement. These questions typically look like this, but not always. We will look at an example where it doesn't look like this. It's not as obvious. So the equation x cubed minus 6x equals 72, and this is a cubic because it's got a cubed term in. It won't necessarily be a cubic, but it probably will be. It has a solution between 4 and 5. That's a big clue. They're telling you the answer is somewhere between 4 and 5. The solution is not 4 and the solution is not 5. It's between 4 and 5. Use a trial and improvement method to find the solution. Give your answer correct to 1 decimal place. You must show all of your work in. Now, in this case, the best thing to use is a table to keep track of what you're trialing, okay? Trial and improvement. And what you're actually trialing is values for x. So this is going to be our trial column, our trial for x. Then whatever we trial for x, we know that x cubed minus 6x is going to have to equal 72. And then this column down here is just for a comment or an evaluation of each trial. Okay, so I've set my table up. Now, they've told me the solution's between 4 and 5, so the first things I'll try are 4 and 5. And because it's between 4 and 5, I should know that when I substitute 4 into this equation, it's going to end up as being too small. When I substitute 5 in, it's going to be too big. I know that's the case because it's telling me it's between them. However, that doesn't mean I don't need to show it. I still should. So this would be, of course, in brackets because we're substituting, 4 cubed minus 6 lots of 4 equals. I tap that into my calculator and that's going to end up giving me 40. I wanted 72, as I predicted. 40 is too small. So I try the 5. I substitute it in. 5 cubed minus 6 lots of 5 equals. Once I've substituted that in, I should see that that is equal to 95. I wanted 72, 95 is too big. Now, just to show you, in order to save time, when you're entering this on a calculator, so if I do the top one, 4 cubed, I'm going to type 4 in a bracket, and then I'll press the cubed button, which is this one, cubed. So 4 cubed, take away 6, open bracket, 4. It looks like that. Press equals. Okay, that's where my 40 came from. Now, I'm not going to retype it to put the 5 in. Instead, I'm going to just record the fact that when x was 4 equaled 40. I'm going to use the back button and go back into wherever I had the 4 in my bracket. I'll then press delete because that gets rid of the 4, and I'm going to put a 5 there instead. Back into the bracket, delete, put 5 there, press equals. That's 95. So I've done those two. Now I need to go in between. I could be clever about this and say, well, is 72 closer to 40 or 95? I'm not going to be. I'm not going to be clever. I'm going to go straight down the middle. That is the safest option. What's halfway between 4 and 5? Well, it's 4.5. To my calculator, again, I'm not clearing anything. I'm just going to press back and I'm going to enter inside the bracket 4.5. And I'm going to press equal, and that's going to give me, when I press SD, 64.125. 64.125. I wanted 72. That's too small. I need to go a step bigger. I'm not going to take any shortcuts. I'm going to try 4.6 next. When I put 4.6 in, it gives me 69.736. I wanted 72. That's still too small. You may have noticed I've stopped writing my equation out here. That's fine. I've shown the examiner what I'm doing. I'm not going to write it out down here. If you're more comfortable with it, then go ahead. So 4.6 was still too small. I'm going to try 4.7 next. When I put that in, it's going to end up being 75.623. I wanted 72. That's now too big. At this point, I need to be aware that the question wanted me to give my answer to 1 decimal place. These all have 1 decimal place. The fact that I've got to a point now where one is too small and the other is too big, and they're both to 1 decimal place, that means one of these two is going to be my final answer. Yes, I need to go to 4.65, but I'm purely doing that as a test to see which value I should pick. 4.6 was too small, 4.7 was too big. I could just look and say which is closer. I'm not going to, because I get a mark for showing that I know if you get one too small and one too big, then you go down the middle. So I'm going to try 4.65. When I put that in my calculator, I end up with 4.65 gives 72.644 and so on. Now I just wanted it to be 72, so that value there is too big. Now the fact that the halfway value was too big means that of course the 4.7 was far too big, and because it's too big it means we select the 4.6 because it's the smaller. If you want a visual representation of why we're picking 4.6, essentially if we had this on a number line, I've got 4.6 here and I've got 4.7 there. And 4.6 gave me 69 point whatever, and 4.7 gave me 75.623. I've tried 4.65 in the middle. That came out as 72.6 blah blah blah. Whatever it came out as, it was too big. So it cannot be anything up here, because it's all too big. So I know that my answer is going to be down here somewhere. And because I don't want it to any more degree of accuracy, I just select the lowest one. That's why the answer is 4.6. Here's one for you to try. In case you can't see it very well, the equation is x cubed plus 2x equals 110. The solution is between 4 and 5. Give it to 1 decimal place. Press pause, have a go. When you're ready, press play, and I'm purely going to give you the answer to x. Okay, so in this case, once we've done all our working out, we'll end up with x equals 4.7. Here's another one. Question 12, if you wish to have a go, it's x cubed minus 2x equals 125. The solutions are between 5 and 6. Press pause, have a go. When you're ready, press play for the answer. And the solution is x equals 5.1. Here we have another quite complicated algebraic question. The reason I'm showing you this in the trial and improvement section is because part B, hidden away, is, and they have been nice and explicitly said use a trial and improvement method, but they've hidden it away at part B. A lot of people would look at this, they'll see the fact that it's one of those show questions, not great with algebra, I'm going to miss this out. Never do that. Read the full question. You can have a go at these show ones, but don't ignore the fact that part B is actually pretty simple. However, we may as well answer this. I'm just going to quickly do the top one. The diagram shows a cube and a cuboid. This is the cube, that's a cuboid. 3D square, 3D rectangle. All of the measurements are in centimetres. The volume of the cube is 100 centimetres cubed, more than the volume of the cuboid. So they're not saying that the volume of the cube is 100 centimetres cubed. They're saying it's 100 centimetres cubed more than the cuboid. And then they say show that. Right, forget about the algebra for now. I'm just going to think about that 100 centimetres cubed and what do they actually mean. The volume of the cube is 100 centimetres cubed more than the volume of the cuboid. So if the volume of the cube is more, then that means that the cube is the larger of the two, and therefore, if I know what the volume of the cube is, and I take away the volume of the cuboid, I'm going to end up with 100 centimetres cubed. The fact that they've mentioned volume is a good indication that you're going to need to find the volume in this question. So I'm going to start by finding the volume of this cube. Now, volume came up on paper 1. It was question 1, but that doesn't mean it won't come up again in algebra. The volume of something is the area of the cross-section times by the depth, or in this case, x times x times x. So the volume of this is really easy. It's just x cubed. And then I'm going to look at the volume of the cuboid. The volume of this cuboid is going to be 2 times by 5 times by x. 2 times 5 is 10. 10 times x is 10x. So what I said was, if I take the volume of the cube and subtract the volume of the cuboid, I'm going to end up with 100. So there's my cube, take away the volume of my cuboid, that equals 100. And there you can see I've matched up with what they wanted, and it wasn't that difficult. So for part B, you should be able to answer this. Now use a trial and improvement method to find the value of x. So they want you to use the equation from up here, and that is x cubed minus 10x equals 100. Set up your table of values. They haven't told you what values it's between. You can have a little go at that, knowing that it's going to have to equal 100. Press pause, have a go, I'll put the answer up. Okay, hopefully your calculator skills are good enough so that you could very quickly try all the different integers. Maybe you tried x is 1 and got minus 9. X is 2 minus 2, x is 3 minus 3, x is 4, 24. Either way, the solution lies between 5 and 6 is what you should have found. X is 5 would give you 75, which is too small. X is 6 would have given you 156, which is too big. You go halfway between. 5.5 was too big, so you drop 1 down. 5.4, still too big. Try 5.3, too small. Jackpot. I found too big and too small, and they are to 1 decimal place. That's what they wanted the answer, so I know one of those has to be my solution. I'm going to use 5.35 as a test just to check which one to pick. That gave me 99.6, which is too small, so I pick the larger of the two, which is 5.4, and that's your answer.